This is Knowledge Engineering with Semantic Web Technologies. And this is lecture number 5, Ontological Engineering. Today, we want to start with you this new topic. First of all, let's consider knowledge management. Ontological engineering, of course, is part of this activity in knowledge management. How does data become to knowledge and wisdom? So usually you have here several stages of data and knowledge management and engineering to create something like knowledge or wisdom. So this is often here explained with the help of this pyramid. On the lowest stage here, you have the raw data, the raw characters, the raw symbols, which, if you consider data also as a message, might be the discrete and objective facts about an event, for example. But before you can make use of it, before the information is in a so-called usable form, you have to understand relations between the data items. So you really have to describe the things. What is what? If we come back to the message metaphor, this means a message becomes, from the data you have, that is meant to change the perception of the receiver who receives the message. And this is only possible if you really make sense of the data, if you really can understand the relations. What is he talking about? But in the end, to consider also context, you need context, for example, you need experience and your values, and you have to apply this to a message really to create knowledge out of the information. So only if you are able to value this information, if you understand patterns, if you look for patterns, how does things work, why are things working, then from simple information there becomes knowledge. But this is of course not the end, simply to recognize patterns. The next thing is you have to understand the basic principles behind that patterns. Only then from knowledge you can go to the point where you reach wisdom. So then you can answer questions like, for example, what is the best thing to do? And what are the right things to do? So then, of course, to your message, then this is the collective application of knowledge, and everything is put in context. If you relate this to time, for example, when you create or build up knowledge, all these activities are related to things you have received in the past. So you can explain things that happened to you in the past. If you also have experience and knowledge about one step further, if you go to the wisdom stage, if you have the wisdom, then also you can extrapolate your knowledge to the future. And with the help of understanding basic principles, you can make predictions. You can really also understand novelties because you understand the principles. So this is even one step further. So this all are activities which are part of knowledge management, and also ontological engineering here is part of that process. So let's get one step back and let's ask the question, what is an ontology? From a philosophical point of view, we have a long time ago answered that question and said, okay, an ontology is a theory of being which tries to explain the being itself. So that's the first part. And also the ontology tries to do this by developing a system of universal categories and their intrinsic relationships and all the stuff. And for computer science, we have simply, or really simplified this kind of message to an ontology as an explicit formal specification of a shared conceptualization. And this is, of course, the notion of an ontology we are using here in the Semantic Web Technology lecture. Okay, so these are types of ontologies we have already considered. You remember this top-level ontology, which tries to explain the world itself, or upper-level ontology. And then we have these domain and task ontologies, which are referring to specific domains, for example, to healthcare, or to specific tasks like, for example, washing clothes or stuff like that. And how do I really create ontologies on that level? This is quite difficult, of course. And how to do that? There are certain methodologies, and these are part of so-called ontological engineering. So this is the topic or the stuff we are talking about now in the next part of the lecture. So what is ontological engineering? So first of all, ontologies enable interoperability among metadata. So therefore, first we need methods with which we are able to design and to create efficiently ontologies. These are methods of so-called ontological design or ontology design, which is part of ontological engineering. Then we need methods for efficient comparison of different ontologies. This is subsumed under the notion ontology mapping. And then, of course, if we have different ontologies, sometimes it's necessary to combine ontologies to a new ontology. And this would be then ontology merging. So these are all methods or technologies which belong to the part of ontological engineering. And then, of course, there are also automated methods that support this ontological engineering, like, for example, learning how new ontologies can be created from a given set of information resources. So, for example, from text document. This would be then ontology learning. Or if you have already an ontology available, if you have classes, for example, and then you are looking at text documents which contain information, there are methods which are able to extract individual or instance information from text documents and combine that with an existing ontology. So they populate existing ontologies with individuals from information resources. And about all these things, we want to talk in the course of this explicit lecture. Okay. So first, let's start with methods for efficient development of ontologies, the so-called ontology design. For the ontology development process, we need some kind of methodology, simply because not all ontologies are really small and we can somehow create them over the thumb. So if many people are involved in the creation of ontologies, if you have to guarantee that ontologies are consistent during also the course of the development and the creation, you have to follow specific methodologies, like, for example, in software engineering. Therefore, also in ontological engineering, there are methodologies, for example, for ontology design. And these are things we will cover here in this part of the lecture. So let's have a look at methodologies of ontology design. So a methodology of ontology design describes all activities which are necessary for the construction of an ontology. Why do we need a formal methodology? I have just explained it. First of all, we want to develop consistent ontologies, so they should not contain failures, inconsistencies. At each single stage of the development, we want to guarantee that what we are doing is really correct. So we need a methodology which guarantees exactly that fact. Then, of course, we want to avoid redundancies. Of course, we want to do development as efficient as possible, especially for complex ontologies. And many times also, not all people working on an ontology are together in the same room. They are distributed potentially all over the world. Therefore, you need a methodology which enables then also distributed development activities. So these are all reasons why we need specific methodologies to develop ontologies. According to Fernandez Lopez and a few other people in the late 1990s, we distinguish several activities during ontology design. First of all, there are management-related activities. We will go into detail later on. Then there are development-oriented activities. And of course, there are also something called ontology support activities. Okay. Overall, they can be subsumed in one single picture. You have here all these management activities which are on the left part of the screen. So you see here, for example, scheduling, control, quality assurance. This is related to management within the ontology design process. Then you have support activities like, for example, knowledge acquisition, evaluation, integration, documentation, merging, configuration management, and so on. They are supporting the design process. And then there is the design process itself, which again can also be structured in so-called pre-design activities, which are environment studies and feasibility studies. Then you have the design or development-oriented activities, which are the specification, conceptualization, formalization, and implementation. We will talk about that. And then, of course, also you have post-development activities like maintenance or use and reuse of your ontology. Okay, let's have a closer look at these design activities. First of all, there is scheduling. Of course, for the scheduling, you have to identify which tasks or problems have to be tackled and covered with the design of this ontology. And then, of course, you have to arrange and you have to plan how the tasks and the problems that are to solve, so in which order they should be worked upon. And you have to identify also which resources are required to fulfill all your tasks. So you have to do the planning about time, about memory and all the stuff. So these are all scheduling activities, and they are, of course, really important. Then on every stage of the ontology development, you have to guarantee the correct execution of all the tasks and all the problems that are to solve. So this is the control part of the ontology management activities. And of course, you have to guarantee the quality. So quality assurance is a rather important issue. You have to do quality assurance of all produced resources during the development. And this concerns not only the ontology, but also the software which works with the ontology, and also, of course, your documentation, which is also an important part of the ontology, because without documentation, potentially, humans are not really able to understand and to see what's going on there and can decide whether this design is correct or not. Okay, so this was management. Now let's have a look at the ontology development-oriented activities, which, as I have previously said, can be structured in pre-development, development, and post-development activities. So before we really start with the ontology development, first we have to do an environment study, which means, okay, I have to know in which kind of software really then will use the ontology. So what kind of program, what kind of application is it that uses this ontology? What kind of software platform do I have? So do I really need huge servers? Do I do reasoning, or do I do other things? And which applications in the end should use these ontologies? This is my environment study. And of course, this influences then in the end also the outcome of my development activities. And overall, before I really start coding and do things, of course, I have to take into account, is this what I want to realize? Is this really feasible? So can the ontology really be developed, or is it too complicated? Doesn't it make sense? So I have to ask the question, does it make sense to develop the ontology or not? And only if I can really positively answer that, then of course I can really start with my development activities. And these development activities from specification to implementation range here from a rather abstract activity, which is the specification, to the most concrete activity, which is on the bottom of this pyramid, which is the implementation. So here we start with the specification on the most abstract layer. So here we ask, for example, why is the ontology developed? What is the benefit? Who are the end users? So there I specify, or I try to generate all the specifications that the ontology that I want to develop should match. This is the specification part. Then I try to structure my domain knowledge that I have, that I want to cover within the ontology, within a so-called conceptual model. This is, of course, not already an OWL ontology, for example, but I simply try to structure everything. I want to gather the vocabulary that I need. What are the important concepts? What are the classes? How are they related to each other? So I do a conceptualization. And this I do on a rather informal way. Then the next part would be also to apply formal methods. So I have to formalize my conceptual model within a computable or semi-computable model. So I have to use, for example, first-order logic or description logic. So I have to make a choice. Which kind of language do I use? Which kind of expressivity should my representation language have? And of course, this then in the end also influences the kind of applications that are possible with the help or based on these ontologies. And only then, if I really have made all decisions that have to be made, and if I have an informal model of my ontology that I want to implement, I can start with the implementation and I can start to construct a computable model of the ontology in some kind of representation language, like, for example, RDFS, or like one of these OWL dialects that we have already learned of. These are the development activities. After that, we have the post-development activities, which in the end consists of maintenance. Of course, when I have already developed my ontology, then of course updates might be necessary or adjustments, simply because reality is constantly changing. And of course, my ontology only represents a specific point in time and must be adapted to reality if necessary. So these are maintenance activities. And on the other hand, of course, my ontology should possibly not only used within the designated applications, but as well in unplanned applications. So then possibly I have to adapt either other applications to my ontology, or vice versa. I have to adapt my ontology if I want to reuse it somewhere. So these are use and reuse activities, which are post-development activities and which are also an important part, because we do not want to invent the wheel each time. You know, if something already exists, of course, we can reuse it. And therefore, we should, of course, also think about how to reuse the stuffs we have developed. So therefore, this is also part of the development, or here, the post-development activities. Then there are, of course, more activities, which are called here ontology support activities, which start usually with the knowledge acquisition. So usually the knowledge engineers or the computer scientists who program or who design the ontology, they are not the domain experts. So they are not the experts in the field who are, for example, for the biomedical domain, the experts that really know how the knowledge there is structured. So one really important part of ontology design is the knowledge acquisition. So either you have an intermediary who asks these experts, who have no ideas of ontologies, of course, but who know their domain, and then you translate this to an ontology, or you have trained, specialized knowledge engineers, which are also computer scientists, who are able themselves to ask or to question the experts and to extract the knowledge and to create from that the ontologies you want to develop. So this is the knowledge acquisition part, which is really a critical part. Of course, you want to make sure that your ontology fulfills in each step of the development process certain specifications. So you have to develop application techniques. So this is a technical evaluation. And therefore, evaluation also is a part of the ontology support activities. As well, of course, as the reuse of already existing ontologies. Sometimes you can simply take an ontology which somebody else has created, if it's publicly available, and then you can integrate it in your own ontology. You can reuse it, and possibly also you have to adapt it. So therefore are also these integration activities. And if you have two activities, so let's assume you, for example, develop your own ontology and you have identified another ontology which could somehow be connected to a new ontology to develop, then also you have to apply ontology merging, so you construct then a new ontology from already existing ontologies, here again within the domain you have chosen. So these are ontology merging activities. What else? Okay, so if you now really apply different ontologies, then you need mappings. And these mappings are usually also called alignments. So if I try somehow to map data from one ontology to another ontology, I have to define a mapping. I have to define an alignment. These are so-called ontology alignment activities. And of course, each single step during the development process should be documented. So accurate documentation really is crucial for humans to understand what the ontology is about, why certain decisions have been made, and why the ontology is really structured that way and not in another way. And of course, in the course of your development, you might have several revisions of your ontology. So you also need a configuration management, which manages all the versions of documentation and all the versions of your developed ontology that is already there. So configuration management should not be underestimated. So this is also a really important task within the ontology design. And you see all these activities usually are addressed within an ontology design methodology. So this is a meta methodology which tells you which parts should be addressed in an ontology design methodology that you try to apply. Okay, and in the next part of the lecture we want to go down deeper into ontology design methodologies, and I will tell you about a very, very simple methodology, which is the 101 ontology design methodology.